Okay, hello everyone. Welcome to PyCon 2021. Thanks for signing up for this tutorial. Yeah, let's go ahead and get started. I'm going to have these slides up at bit.ly/simplepycon2021. And yeah, feel free to just post any questions that you have to the chat. So here's the usual information. So I've made these slides in a lot of bullet point formats, so you don't actually have to take notes unless you want to. You can always refer back to these slides. In fact, including during this tutorial, I really recommend having just a tab open with these slides so you can go back and forth independent of where I am in the slides. And yeah, so who am I? I'm Al Sweigart. I'm mostly known as the author of Automate the Boring Stuff with Python, and I have been writing Python books and programming books for beginners and kids and adults for, well, over 10 years now. That's And yeah, why learn Python? I'm sure nobody needs to be convinced. Python, I'm convinced, is the easiest first programming language to learn, and this is who should be taking this tutorial is people who have no experience at all with Python or programming, and they have just heard a lot about this Python thing, and they want to get sort of get their toes wet. So what you'll learn by the end of the tutorial, it's always hard to sort of quantify, what you should know at the end of the tutorial. We're going to be spending 2.5 hours. I'm just going to be covering a lot of introductory material. I don't really expect you to memorize a lot of this stuff. There's some interactive portions with this where you'll be typing code into your interactive shell or into idle or Visual Studio Code or the Mu code editor. I sent out an email about installing Python. If you don't have Python installed, you just couldn't get that done, that's no problem. You can go to this website, pythontutor.com. I'll just post that into the chat and click on Start Visualizing Your Code right now. And this gives you an editor that you can enter Python, and then you can click Visualize Execution to run the code. This isn't as nice of an editor for a few different reasons as just having an actual code editor like idle or Mu on your desktop. But if something happens, you can always just go to this website, pythontutor.com. And yeah, we'll take a couple short breaks, probably in an hour, and then 45 minutes after that. And do go ahead and ask questions, because one of the great things about having this live tutorial is that you have access to me right now. You're not just watching a 2.5 hour long video. So if you have questions, go ahead and ask them. Yeah, of all these slides, I usually do a slide presentation where I only show one bullet at a time, so I'm not just sort of reading off of a wall of text. But with the format for this virtual conference, I figured it'd probably be best to always have all the bullets on screen all the time, except for this next part, where I reassure you about learning to program, because programming is often a very intimidating thing. I've taught adults and kids how to program, and kids are usually less intimidated because they don't have that preconceived notion that programming is rocket science or brain surgery or something like that. So let me first just say, in a very soothing voice, relax, hello, welcome. Welcome to this tutorial. First, let me reassure you, you don't need to be good at math to program. This is a very common misconception. If you didn't do well in high school algebra, that's fine. You don't really need those sorts of math skills in order to be good at programming. You're not too old to program. I get this is the second most common worry that people send to me. It's really funny too, because people will say like, well, I don't know, I'm already 23 years old. Is that too late to start learning to program? It's like, no, it's fine. Yeah, you're not too old to start learning to program. You don't need to be a computer scientist to program. You don't need to have a computer science degree. You don't even need to want to become a software engineer. Programming is a little skill that can be a fun hobby and maybe just automate some stuff on your computer. You don't have to have a in-depth academic background to be able to program. It's okay to constantly be Googling for something while you're programming. I'm a professional software developer. I've been programming for over 20 years, and I still Google 30 times a day, just random stuff. This field is just too wide. You can't keep it all in your head at the same time. Everybody Googles. It's fine if you're still Googling even the same things over and over again, just to look up that information. And it's okay to make bugs. Again, I've been programming for decades, and I'm convinced I still write bugs into my code at the same rate as when I first started. It's just the nature of software development and programming. The really great thing about computers is that they will do exactly what you program them to do. And the terrible thing about computers is that they will do exactly what you tell them to. And crashing programs does not damage your computer. You're not hurting your computer, you're not wearing it out or anything like that. The worst you could do is delete some files, but we're not even going to be touching any of that sort of stuff. So nothing you do during this tutorial will mess up your computer in any way. And then finally, if Python stops working for you during this tutorial, something happens and idle crashes or mu crashes and you can't start it up again, you can always go back to that website, pythontutor.com, and use that to follow along with the interactive shell examples. Okay. So what I really like to do before I go into programming is talk about how to get programming help online. We're really used to I don't know, learning things in school where you have a human teacher who you can ask questions, but the nature of finding help online is a bit different, mostly because if I post a question or I email somebody a question, they might not reply for 2 hours or 2 days. And when they do, I might not reply back to them for 2 hours or 2 days. And then they might need to email me again to ask me more questions. So the thing about asking for help online is you want to minimize the amount of back and forth. And so there's a lot of things you can do. First is don't be afraid to Google things yourself. It's a 99% chance that somebody else has had your exact same problem before. And if you Google the error message that you're getting, just copy and paste it into a search engine, you'll find lots of other people who have had that exact same problem and somebody else has posted a solution. It's so much quicker to ask a search engine for an answer than to ask a human being. Talk to a rubber duck. So this is known as rubber duck debugging. A lot of boot camps would just hand out like little rubber ducks and they would say, yeah, just put it on your desk. And when you have a problem, explain your problem to this rubber duck. Actually articulate what's going wrong. And just the act of putting it into words will help give you a more concrete idea of what it is that you're doing. And then that might give you an idea of what you're doing wrong and something else you can try. And anyway, if you've tried both of these things, but you still want to ask someone else online, there's a lot of tips for doing this. First of all, don't ask to ask. It's really polite to do that in person, but if you just send someone an email saying, "Hey, I have a programming question. Can I ask you?" The answer is either going to be yes, or they don't reply to your email ever. So go ahead and you do want to put up as much information up front as possible. So have your question, have your code that you're running, have copy paste the error message that you're getting. You basically want to have it's better to have too much information than not enough. You really want to be specific. A lot of emails I get and I see online are just a person saying, my program doesn't work, which doesn't really tell your helper much of anything. Anyway, so these are all just sort of how you can make the most efficient use of time when you're asking for help online. I have a blog post that goes into more detail about it here. My website, inventwithpython.com, I have a URL shortener for that. invpy.com/help will give you a link to that blog post. Okay, so if you have installed Mu, or perhaps you have some other Python editor that you want to work with, I'm just going to be using Mu for a lot of the code examples here. No matter which code editor you have, though, there's probably going to be two parts to it. There's going to be the file editor, which you can see is right here, and here's where you write all of your code for your program, and then you can click a run button or somehow run the program that you've typed, and it'll run all of the instructions until it gets to the last instruction or it hits some instruction that tells the program to stop. There's also the interactive shell. It's also called the REPL. And this, if you're on Mu, there's a REPL button. It'll pop up with this little prompt right here. And the interactive shell, or the REPL, lets you enter instructions one at a time, and it will immediately run that one instruction. So this is really great if you just have one line of code and you want to see, like, oh, what does this code do? Or what happens when I call this function? What's the output of that? It's really great for just experimenting. And you can always tell the difference between the file editor because it'll likely have a large blank sort of word processor window. And the interactive shell will usually have this prompt. It's the word in followed by the square brackets and number. Or if you are using idle, which is the code editor that comes with Python, the interactive shell will have this triple angle brackets prompt right here. If you click on File, New File, it'll open a file editor window where you can just type an entire program. Okay, so yeah, I'm going to be throwing sort of a lot of information at you. It's okay if you don't memorize all of it. A lot of this is just getting the experience of writing Python programs that are really simple and just sort of seeing how the entire process works. So let's go ahead and do this. If you've opened up Mu right here, usually you'll have something that says like write your code right here. You can erase that. If you have something else, you can click New to open up a new tab right here. Go ahead and write this code right here. This will be a very short program that says hello and asks us for our name, and then it will say, oh, it's nice to meet you, whatever your name is. So I'm going to be doing this off to the side here. But yeah, go ahead and get started with this. And it's okay if you're not entirely caught up quite yet, but I'm just going to click Save, and I'll just save this as, I don't know, sort of hello.py is the name that I'll be saving it under. Sorry for covering up the screen there. And then in Mu, there's a run button at the top. You can just click that to run the entire program. And so it'll start at the topmost instruction and then carry that out and then move it down to the next one. And it looks like this. Now, okay, I have to turn off the REPL. And it looks like this if you made a typo like I did. So for coding, you have to be very precise. The computer only understands very precise instructions written in the Python language. So in this case, I forgot this plus sign right here. So that's fine. If you have some sort of error message, it's totally fine. You can click on save. I'll click on stop here and then click run again. So it says, hello, what is your name? And I can enter Al and then press enter. And it'll say, it's nice to meet you, Al. Now, the nice thing about this is that the text output is this very similar to the text source code right here. So you can see, oh, this instruction printed out this text. Hello, what is your name? Note that it didn't print out the quotes right here. And then we have this instruction right here, my name equals input with these two parentheses. That might look strange to you, but we'll go into that later. This is basically just calling a function that says, okay, let the user type something in, and whatever they type, we'll store it here in this thing called my name, and then later we'll display, it is nice to meet you, plus whatever was stored in my name, which is how we get this, it is nice to meet you, Al. So a little note about this, code editors save these files as plain text files. And so what I mean by that is that the files only contain the text information right here, this text right here. There's no font information or font size or color or anything like that. A lot of editors will automatically, on top of the basic text, add their own coloration so that different parts of the code are colored differently. So these print and input function calls are blue, and this text value right here is in this reddish brown color, and the rest is black. That's all added on top of it later. The actual file itself is just a plain text file, and usually those have .txt file extensions, but Python programs will be these text files, except they'll have a .py extension instead. All right, so yeah, this is the first program. Really something really simple. All Python programs are basically this, but a little bit more complicated. But yeah, this is the entire process, really. You just sort of sit down and you sort of think about, oh, okay, what do I want this program to do, and start writing it out. And then there's the invariable running it, getting some error, fixing that error, running it again, fixing some other error. But it's really great to finally have a program run successfully and perform some calculation or something like that. A really common thing for programmers is just to be typing and constantly saying, like, I hate programming, I hate programming, I hate programming. Oh, hey, the program works. I love programming. It's a great endorphin rush. All right, so next, we've been working in the file editor. Let's go on to the interactive shell. Now on Mu, you can hit the REPL button. And here's where you can enter Python instructions one at a time. In fact, I could just copy and paste this hello, what is your name part in here. Just highlight it, hit Control-C to copy, and then Control-V to paste, and then press enter to run this. And it shows the output of this one line of code. So what I like to do when I'm teaching people how to program is just go through what I call calculator stuff. This is just really simple math stuff that you can do in the interactive shell. Now, so normally interactive shells will have these triple angle bracket prompts. In Mu, it'll have this word in followed by square brackets and a number. That's fine. Go ahead and just type in each of these into the interactive shell, and you'll see the output of what these instructions produce. Now, if you're using pythontutor.com, you're going to have to add print, open parenthesis, and then the text of the code, and then a close parenthesis after that, because Python Tutor is sort of like a file editor in that if you tell it to add 2 and 2, it will do that, like that calculation will take place, but it won't actually show you the results unless you tell it to print it on the screen. So here I've clicked visualize, and then to run the entire program, because Python Tutor will normally just run it one step at a time, you can click on last and then see the output right here. And yeah, let's just go ahead and see what types of instructions, these little calculator problems that we can do. Notice I can also have two with a lot of spaces, and Python interprets that the same. I can also subtract 10 minus 3. And then I could also say 10 plus -3 as well. You don't have to be good at math because, again, the computer is the one doing all of the calculations. The main thing is you have to know the language of the computer, in this case, Python. And if you don't give it instructions in exactly that same grammar, then you're going to get error messages. So here's some interactive shell examples that will also cause error messages. These won't work at all. So let's do 3 times 3 with a lowercase x. And it's going to say syntax error, invalid syntax. Now, remember back when I was talking about how to find help online, probably the first thing that you want to do is just Google the error message. So I would just like copy and paste this into a search engine, and then figure out what does syntax error, invalid syntax actually mean. There's a lot of improvements have been made in the newest version of Python, 3.10, which I believe you can get like the beta version of right now, where they've improved the error messages. But all programming languages seem to have really poor error messages in general. I think programmers, whenever we write code, we sort of realize like, oh, some error could happen, but that's probably not going to happen. We're very optimistic. And so we say, well, if this happens, we'll just say like, oh, invalid input, or an error happened, or something like that, which is not very helpful. But so if you see something like this and you have no idea what this means, and you have all this other scary looking text, don't really worry about that. You're pretty much not supposed to understand what it means. It's very terse and doesn't have a lot of information. Just go ahead and copy and paste it into a search engine to figure out what that means. So in this case, this x is not the proper thing to do multiplication in. You use the asterisk instead for multiplication. Now we could also have 2 plus, and this also says invalid syntax because it's expecting another number to come after that plus here. In math class, you might remember, oh, we could just have a number next to the parenthesis that indicates multiplication, like 3 times this 2 plus 1. That's actually not how you write code in Python. And I think, in fact, it was expecting more text after this, so I had to press enter again. And now it says like type error, int object is not callable. Again, there's no way you could possibly know what that means or anything. Just if you encounter an error message, you can just copy and paste it into a search engine to find the website where somebody actually explains what it really means. So in oh yeah, and then we could do this 2 plus the letter W. Just say you like type that. It'll say name error. Name W is not defined. Whatever that means, it's probably related to this W that you typed. In in-person tutorials, I would usually hand out a worksheet with a whole bunch of different error messages on them, and I would tell people to just like check them off as they encounter them, and just treat it like Pokemon, where you're trying to encounter every single possible error message. Just to remember, like, okay, getting errors is fine. You don't have to feel bad about it. In fact, you know, the more different error messages you see, the more you're learning about Python. Oh yeah, and as far as getting a copy of this presentation, you can find it. I'll go ahead and post this. These slides, you can read them right now here at bit.ly/simplepycon 2021. Okay, so let's go into some vocabulary terms. So these math problems that you're doing are called expressions. And so an expression is a kind of instruction, a Python language instruction. That's made up of values, like the 2 in 2 plus 2, and operators, like the plus sign. And what expressions do is that they evaluate down to a single value. So the expression 2 plus 2 evaluates to 4. And as far as, you know, values can be just sort of any number right here, but the operators, there's plenty of other math operators. There's plus for addition, minus for subtraction, the asterisk for multiplication. For division, it's the /. That's the /, right? Yeah, I think that's right. Anyway, again, if you ever make a mistake, like if I want to say 10 divided by 2, you'll just get an error message, and then you can always copy and paste this error into a search engine. And then there's also some more esoteric math operators. There's // for integer division. This will do the division, but then also round down. Exponents is done with 2 asterisks next to each other. There's something called the modulus operator, which is done with the % sign. This is sort of like a remainder. Let's go ahead and just try all of these out. Here's some more things that you can do in the interactive shell. So let's go ahead and I'll follow along with that. Okay, so 3.14 times 3. You can see now we have numbers that have decimal points. That's something we can do. We could also just do a really large multiplication. Doesn't matter what the number is. Python handles it just fine. Let's try some division. 21 divided by 7. And that'll give you 3.0. And if we try 22 divided by 7, that will give you a pretty decent approximation of pi, 3.14, etc. And then here's that weird integer division operator. It's made up of 2 characters instead of just one. It's // with no spaces between them. So that divides it, the division will produce this, but then integer division rounds it down. So it's actually just 3. And then the modulus operator is sort of like the remainder. So 22 divided by 7 would be 3 remainder 1. So 22 modulus 7 is 1. And we could have 2 to the 3rd power, which is 2 times 2 times 2, which is 8. And then also the order of operations that you remember from math class, that applies to Python's math operators as well. So exponents are done first, or parentheses are done first, exponents are done next, multiplication and division are done next, and addition and subtraction is done last. So if I wanted to do the addition of 2 plus 1 first and then multiply that by 3, I would put parentheses right there. So this might give you the idea that, oh, okay, so a programming language is a lot like a calculator, but it's so much more than that. But these are just really good examples of telling Python something to do and having Python carry it out. So there are other types of values and other types of operators as well. We went over the integer values, those are the whole numbers, but there's a bunch of other so-called data types as well. So we can also have text values, and these are called strings, and we always write them surrounded by quotes at the start and front, so like this hello right here. There's Boolean values, also called bools, and this data type, the Boolean data type, only has 2 possible values, true and false, with a capital T and capital F. So there's effectively an infinite number of integer values and an infinite number of string values, because you could always just create longer and longer strings. But the Boolean data type only has 2 values. The numbers with decimal points, technically those are different from integers. It's a different data type. They're called floating point numbers, or just floats. You can always recognize them because they'll have a decimal point. And then there's the none value, sort of like true and false. It has a capital N. It is the only value of the none type data type. None is used to represent a lack of a value, kind of like what other programming languages will have a similar concept. They usually call it null or undefined. We won't be touching on this. There's also a lot of other data types as well. Plenty to learn from here, but these are the basic ones that we'll be covering in this tutorial. And as far as other operators, there are comparison operators where we're comparing 2 values. This equals equals operator compares 2 values and sees if they are the same, if they are equal to each other. And if so, that expression will evaluate to the Boolean value true, and if not, it'll evaluate to the Boolean value false. We'll do some examples of this on the next slide. And there's this exclamation mark equal sign, which is sort of weird, but in programming, this is the is not equal to operator. So it's the opposite of the equal to operator. Then there's also less than, greater than, and then also there's a less than or equal to and greater than or equal to value. These are commonly used with numbers just to compare two numbers. And then there's also Boolean operators. You might know these from search engines. They're the keywords and, or, and not. We'll be covering those in the next few slides here. So here's some more interactive shell examples. Yeah, let's go through some of these. I'm here in Mu. I'm just going to go ahead and try some of these. Try some of these out. 10 is less than 5. So notice, just like how 2 plus 2, that math problem, is an expression because it's made up of values and operators, this 10 is less than 5 is also an expression. It's made up of numbers and this less than operator. But instead of evaluating to a number, it evaluates to a Boolean value, false or true, in this case, false. We can also try 5 is equal to 5. Remember, these are two equal signs with no spaces in between them. And so that comes out to true. You can also say hello, this comparing this string value hello to this integer value 5. And Python says, no, those are not the same value. But if we ask Python, is hello not equal to 5? Well, that's true. They are, in fact, not equal to each other. But here's there's a lot of little corner cases that we can explore with this as well. So what about the string value hello with a capital H and the string hello with everything capitalized? Python says that's false. Python considers those to be two different values. And this is something that could vary from language to language. Python has decided that string values will be case sensitive. Like, it does matter what the case is. So, you know, the capitalizing the rest of this word means that this is a different string value than this string value where only the H is capitalized. The same thing for, you could have a string, which you always recognize because it begins and ends with the quote characters right here. So even though this is made up of numbers, this is more like the digits 4 and 2 as a text string compared to the number 42. This is an integer value as compared to a string value. And Python will say, well, actually, yeah, those are going to be false. Other programming languages might say, yeah, you know what, they're sure, we'll call them the same. Meanwhile, though, you know, Python says these are different data types, so they're not equal to each other. However, a floating point value 42.0 is that equal to the integer value 42? And Python will say, yeah. In Python, you can have floating point values be equal to integer values. So comparing these two numbers in Python means they're the same, but comparing a string to a number is going to be a different value. Oh yeah, and then let's remember this less than or equal to operator. So that's going to say, is this less than or equal to the other value? And in this case, yes, it's true, because 10 is equal to 10. Now there's also the greater than or equal to operator. Just remember that the angle bracket part always comes first. So you wouldn't say 10 equal less than 10. Python will say, nope, I don't understand that. So it's syntax error, invalid syntax, which is really not a helpful error message at all. But it does indicate, okay, something did go wrong, probably somewhere around here. Okay, all right. Let's play around with the strings inside the interactive shell. So strings, remember, you can always recognize them because these string values will begin and end with quotes. They can also begin and end with double quotes as well. They are the exact same value even. We can even check that in with the equal operator, comparison operator. Python gives you some flexibility. I like using single quote because I don't like to hold down the shift key when I'm typing. And when you're typing out a bunch of code, little things like that do sort of like build up over time. Everybody has their own preference. But yeah, remember, this is an expression. It's just like those 2 + 2 math problems. It evaluates the expression. Python will evaluate the expression down to a single value. And we can use some operators on string values as well. So if I say hello plus world, I'm going to get the string hello world. So this is very interesting. Notice how I don't have a space at the end of hello or in front of world, which is why it just crams all of these letters together. I guess I could also do hello with a space at the end plus world, and it will evaluate to this. So just like how 2 + 2 evaluates to 4, adding two strings together with the plus operator produces one string value. The expression evaluates down to a single string value right here. There's another fun little feature in Python where you can use a string and multiply it by an integer, and this does string replication. It just produces a new string that has all the characters in the string repeated a certain number of times. And here, this isn't a double quote character. In the next example is 2 single quote characters. So that's called a blank string. It's a string that has no characters in it whatsoever. We could just go ahead and add that to hello, and that just produces hello, because of course we have nothing in front of hello. Well, that's still just hello. And in fact, we could even check this out. Let's create some parentheses right here, have the blank string plus hello, sort of this expression, and then we'll compare this value and see if it is equal to just the string hello. And remember, this is just an expression. All of this will evaluate down to a single expression. So this part evaluates to a string, and then it compares that string with this string using the equal to operator. And of course, because it's using this comparison operator, it's going to evaluate to a Boolean value. So in this case, true or false. Now these are, oh yeah, and let's go ahead and try some things that are going to cause errors. If you begin a string with one kind of quote and then end it with another, Python is going to get confused. And this is my favorite error message in the world because it makes no sense whatsoever. Syntax error, eall, while scanning string literal. All of that makes sense once you learn that eall means end of line, and a string literal, it just means this value, this code right here for the string. And what it basically means is that it was looking for a double quote that ends this string somewhere at the end of the line, but it reached the end of the line before it found that. But this error message is completely unhelpful for beginners. But again, if you just copy and paste it into a search engine, you can find people explaining what exactly it means. So we were able to add two integers together, and we can concatenate two strings together to just join them into one new string. We can't actually run, we can't add a string to an integer. Python says that doesn't really make sense. I don't know how to do that. So then it shows this error message. Type error must be str, which is the short term for string, not int, which is the short term for integer. Yeah, some operators you can't use with certain data types. So you can't subtract a string from another string using the minus operator. It's going to give you an error message for that. Remember how we did the string replication by multiplying the string hello by an integer? And you can't use a floating point operator. It's going to, a floating point number. It's going to say, I don't really know how to multiply. I can't replicate this string 3.5 times. And in fact, even if you try 3.0, this decimal point is how you can tell that this is a floating point number. It has like a little fractional part of that number. So this is a floating point number and not just an integer number. So those are two different data types for different values. And Python is also going to complain if you try to replicate a string without any floating point number, even if it ends with 0.0. And so there's just a ton of these tiny little rules about what is and is not valid Python code. And you'll just be learning this over time. The best way to learn this is just by opening up the interactive shell and then just typing code, seeing what error messages you get, Googling the error message to find out what caused that and learn more that way. Okay, so let me take some water. And again, yeah, if you have any questions, make the most of the fact that you have a live person right here in front of you. Otherwise, I'm just gonna keep going on. Okay, so I love doing all the calculator stuff. It's very straightforward, using the interactive shell to explore different types of Python code. But the problem with that is the computer is just waiting for you to run instructions, and then it runs it in a few nanoseconds and then comes back to you. It gives the idea that, like, the computer is like a calculator where it's waiting on you to do all of these things. But as you'll see later, once we start writing more and more programs, we can actually have the computer do millions of instructions in a few seconds without waiting on us. And so part of the way that we do that is we can use something called variables, where we can save values or the results of expressions for use later in the programs that we're going to write. So just a good example right here. Let's just enter this code into the interactive shell. I'm going to say my name, and this is all going to be one word, no spaces, with a capital N, equals, and then we're just going to put a string value. We're going to store any string value inside of it. So begin and end with quotes. And this is called an assignment statement. Now notice that there is only one equal sign for assignment statements. This is a different operator. This is the assignment operator, which is different from that equal to operator that had the double equal signs. So getting those two mixed up is a really common mistake to make. But so what this instruction does, what this assignment statement does, is that it takes this value and it stores it in a variable called myname. And now we can use myname in any of our Python code. And myname will evaluate to the value it contains. So just how 2 + 2 evaluates to 4, you could just have the value 2 by itself, that evaluates to 2. And the variable myname by itself evaluates to the value inside of the variable. So in this case, the string al, or whatever you put right here. And we can use it inside of expressions wherever we use a value. So instead of having some string times 3, I can say myname times 3. Or I could even try myname times 3 million or so. Oh, that might have been a mistake. It's going to take a long time to print that out. Yep. So this is also caused just by the editor itself. It's not really Python, but the editor has to collect all of this text. Oh, okay. I see somebody asking for a 5-minute break. I think we can cover the rest of variables, and then we'll be at the hour mark, and we can take like a 10-minute. Oh, oh yes, sorry. I'm in teacher mode right now, where I take everything literally, just because I don't want someone to ask an earnest question, and then I respond like, that's a stupid question. Of course, you're just joking around. Well, okay. So what's going to happen in this case is I'm going to shut you down. Yep. Okay, close. Yep. Close the program. Yeah, did I mention that I'm a professional software engineer with 20 years of experience? Okay, here we go. Click on REPL to open that up. My name equals Al. Let's just try my name times, how about 30 instead? Okay, there we go. Uh, yeah, there is a little bit of slowdown when you're using the interactive shell, mostly caused by just getting all the output to display on the screen. If you write code like this in a normal Python program, Python handles it just fine. That's just uh, messing around with data in the computer's memory. But really, once you have to like, oh, we need to like display all this text in a window, that tends to be slow on the order of several seconds or maybe never in this case. Okay, so the thing about variables is that they're not like variables in math class that you've learned. Their contents can vary. So we could say my name, have another assignment statement, and I'll just say Zophie instead. And now if I run that same code, my name times 3, uh, now the value inside my name is this string. So this expression now evaluates to this string. And so this is what we're going to be doing with our programs is we're going to be sort of talking more abstractly about data. We're not always going to be directly typing in 2 plus 2, but rather we're going to say, hey, we have some data here in this variable, do something with that with some other data. We'll be combining those. And so we won't have to be literally telling the computer every single instruction to do, because that would be incredibly slow. It'd be as slow as we type out the instructions. Computers are way faster than our fingers, so we instead want to use these concepts like variables instead. Okay, so a little thing about variable names. They're all going to be a single word without spaces, and they are case sensitive. So my name with a capital N and lowercase m, this is going to be different from a variable with all lowercase or all uppercase letters. Just a little tip for when you're writing programs, if you do have a variable named my name, technically you could have other variables with slightly different names, and Python, it's all the same. Python doesn't really care what you name your variables. But this is an easy way to trip yourself up later because you'll easily get them confused when you're looking at your code later on. And variable names can have letters, numbers, and the underscore, but they can't begin with a number. So you could have a variable named name3, but not 3name, because Python will start looking at this and see the number and think, oh, you're typing like a number out, and then you have some random text after that, and Python will think like, okay, this is not grammatical Python, so it'll show you an error message. And if you have a variable with multiple words in it, kind of like my name, you can use camel case, which is what they call when you have all the words squished together with a capital letter differentiating the words in this. Or you can have snake case, where you use an underscore character to separate them. Now, technically, there's this document called PEP8, which has a style guide, which is like how you should write code, and PEP8 says you should use snake case. I personally just never liked typing underscores. I always felt that this was like one extra character that you would have to type. And I'm really used to typing camel case. And lots of people say, well, technically, PEP8 says you should use snake case. It really doesn't matter. To Python, it's all the same. Remember, Python doesn't care what you name your code. And in fact, PEP8 will also has another section that says, you don't have to strictly abide by everything here. This is just like a list of suggestions. Write code that makes sense to you, and that and as you write more code, you'll pick up more tips about like what makes for readable code and everything like that. A lot of best practices for programming. Some of those are actual best practices and good ideas, and then others are just sort of the opinions of some programmer who then later wrote a book, and now people treat it as authoritative. As a tech book author, I can tell you, like, yep, I totally do that all the time. I try to pass off my own subjective feelings about code as best practice. Yeah, it's fine. Okay, next, comments. This is text in your program that are ignored by the computer. They're actually meant as little notes and reminders for you, the human programmer. And so comments in Python begin with a hashtag mark and then go to the end of that line. So I can have some code right here, print hello, and then at this point with this hashtag right here, everything after this is ignored by the computer. You can type whatever you want, but you can just leave a little comment to yourself to explain what the code is doing. This isn't a very good comment because it's quite obvious. Oh yes, this is printing hello. But usually you'll have some comments throughout your code. So that way when you look at your program's code 2 weeks from now and you haven't really been, don't really remember it, you can remember, oh yeah, you just read the comments that explains what you were doing and why you were writing your code this way. It's very helpful. It offers some documentation for how your program works. You can also do multi-line comments by using triple quoted strings. So these are string values that instead of beginning and ending with a single quote or a double quote, they begin and end with 3 single quotes or double quotes. So the thing about that string is that they can have new lines, and that's still considered part of the string value. So, and Python makes use of these triple quoted strings as comments that span multiple lines, because if you just have a string value in your program, Python doesn't really do anything with that string value. So effectively, this is a way of just having comments in your code. All right. Let's see. Do I want to go into? Yeah, I think I can go into functions and importing modules, and then we can take our first break right there. Okay. So functions. Functions, the best way I've found to describe functions is that they're like a mini program inside your program. A function will contain some bit of code that does something, and you can have your program run that code and do that thing by calling the function. So 2 functions that we've already seen are print and input. When we have this print function call right here, it will run some code inside the print function that causes text to display on the screen or in the window. And then the input function, when we run that, it waits for the user to type something using the keyboard and then press enter, and then it returns that. So print and input are great because this is a way that you can send output to the user and inform the human user what's going on with your program. And then input lets you get text-based input from the keyboard from the user. Now, function calls can have some inputs. These are called arguments. Those are just values that you'll put in between the parentheses. And a function call itself can evaluate to a value. It can be part of an expression. And this will be the output of the function, and we call that the return value. And then later on, we'll see you can also define your own functions in your Python programs using these def statements. So as far as just a little example, let's try out something in the interactive shell right here. Let's call the len function. Now functions, you can always tell functions because they'll have the parentheses, the open and close parentheses after them. In this case, there's a function called len. In fact, let's not even look into what len does. Let's just go ahead and run this code. And we have this argument, this string value right here that we pass it. And we can see that, okay, and we can see that it returns the value 5. So len is a function that returns the length of the argument. So in this case, this string value has 5 characters in it, so it returns 5. And remember, we can just use this as part of any expression. So this is a function call. It will evaluate to whatever the return value of this function call is, in this case, based on the input here, this string value right here. And then we add that value to 2, and then that entire expression just evaluates to 7. So this was just 2 plus 5. Python has a whole bunch of different functions that are built in. If you have a nice looking editor like Mu right here, as soon as you start typing, they'll start popping up with this information right here, telling you, giving you a brief little summary about this. Usually it's better to actually just look up a tutorial or some like a website or something to explain. But this little bit of help text right here gives you it's a nice reminder once you've already learned what this does. So let's call the round function. I'm going to pass it. I'm going to pass the float value 3.1415 to round, and it returns the integer 3. So this is just rounding this number, either up or down. You could use these inside of an expression. And then some functions will take a variable number of arguments. So there's also a version of round that we could call passing 2 arguments. So in this case, the first argument is going to be the number that we want to round, and then this is how many decimal places we want it to round to. So in this case, we want it to round to 2 decimal places. So this returns the float value 3.14. And what the arguments are for a function call and what it returns entirely depends on the function. For length, it's going to accept a string and return an integer of the length of that string. For round, it's going to accept either a floating point value or a floating point value and an integer, and then it'll return some number value that it rounds to. So we'll get into creating our own functions later on. So yeah, functions are great because they let you use code that have been written by other people. So you don't have to know how round works or how len works. You just have to know what it does as opposed to how it does it. And so there's another thing called modules, and modules are other Python programs that can contain their own functions. And if you import these modules into your Python program, you can then access that module's functions. So this is a great way to have code reuse. Now, when you install Python, the Python language comes with something called a standard library. And it's a set of these modules that any Python installation should be expected to have. So I'm going to just go ahead. We can start with this interactive shell example right here. So in order to import a module, I'm going to have to type the import keyword followed by the module name. And we'll be learning about lots of different modules. For our purposes, since we're going to be making a lot of small little games, we're going to be using random numbers a lot in these games. Just think of how many games involve dice rolls or coin tosses or that sort of thing. So this is an import statement. It's not an expression. It doesn't evaluate to anything. It just tells the Python interpreter, go ahead and import random for this program. And then once we've imported a module, we can then call the functions inside that module. So in order to do that, I have to type the module name followed by a dot, followed by the function name. In this case, randint. This will return a random integer, and we'll pass it 2 integer values because we want this to return a random integer between 1 and 100. And one thing I can do in Mu is just press the up arrow key, and that will go up through the history of previous instructions that I've given it to type. So I could just keep hitting up and enter and up and enter. And you can see this function returns a random integer value between 1 and 100, including 1 and 100. There's also a math module, which contains a square root function. So if I wanted to find the square root of 25, it returns that 5. And that makes sense because 5 times 5 is 25. So the square root of 25 is 5. And again, like this sort of like grade school math is pretty much the maximum amount of math that you really need for most programming most of the time. Yeah, and so these modules like math and random, those are part of the standard library with Python. Python, when you install Python, they come with Python. But there are also third-party modules, and this is where Python's utility really shines. Most of these are hosted on a website called PyPI, the Python Package Index.org. I can go ahead and just open this. And there are believe hundreds of thousands. Yeah, hundreds of thousands of different projects for doing different things. So if you want to have a Python module that can post to Twitter for you, or um, read PDF files, or I don't know, like all sorts of things. Um, Probably somebody else has already written code to do that, and you can download and install that module using a tool called pip. Now, this is all beyond the scope of this tutorial, but just to give you an idea that Python is really great because there's such a huge community behind it, and they've written a lot of code that they've made freely available for everyone to use. Uh, Far more sophisticated than just this sort of random number and simple math stuff. It's really sort of the true strength of Python is its community. Okay, it is a little bit past 3 o'clock. I think it's probably a good time to take like an 8-minute break. Yeah, if you have any questions, you can feel free to just post those into the chat room, and I can get back to them uh, at the end. Let's go ahead and take about 8 minutes, although probably it'll be 10 minutes. But yeah, 8 minutes, and then I'm just going to leave running another little program that I wrote that is a ASCII art fish tank that I wrote in Python, and it looks like this. Okay, I'll see you in 7.5 minutes. Okay.
Welcome back, everyone.
Hello. Okay. Yeah, I'll just talk about the fish tank just in case there's a couple people who haven't gotten back yet. Yeah, so I have a collection of these sort of text-based programs that I created mostly as examples of programs that are short and simple and easy to understand. A really common thing for a lot of beginners who sort of learn the basic syntax of the Python programming language, but then they don't really know what do programs look like. They want to make the cool thing, but how do they turn, variables and function calls into that cool thing? And a lot of people will tell them like, oh, well, you should just look at the source code of open source projects, which is actually terrible advice because most of those projects are going to be written by experts. They might not be well documented. I know my open source projects aren't really as well documented as they should be, and so there's this massive complexity, and if you just sort of try to dive into that, it's really intimidating and you won't be able to understand it. So I wanted to have a collection of programs that were like under 250 lines of code. And in fact, some of the projects that we'll be working on at the end of this tutorial are from that collection. So yeah, one of them is just this text-based fish aquarium right here. Okay, let's go ahead and stop that. Okay, again, yeah, I wholly encourage everyone to go ahead and post questions that they have, or if they just want me to explain something in another way. You have access to a live instructor right now. Go ahead and take advantage of that. And yeah, okay, let's continue on. Okay, so we've talked about expressions and how they're made up of values and operators, and there's different types of values and different types of operators. Um, and you can also store these values in variables and use them later on. And there's a bunch of functions that you can call that have some other sophisticated behavior that you can have carry out. And it's great because you don't have to know the code in that function. You just have to know what the function does. Sort of like, you can drive a car without being a mechanic and understanding how a car works. You just know that you have to keep it full of gas and how the brake and steering wheel works. So the same thing with a lot of programming. There's so much software that's been written. No one person can understand all of it. But you really only have to understand a little bit to start doing useful things. And that's one of the main strengths of Python, is that it's such a great language that it lets you quickly get up to speed and doesn't really get in your way with just creating simple programs that just make your life easier. Okay, so yeah, just as we have values that are string, like string values that are text, and then we have like floats and ints for numbers, and then true and false for Boolean values, we can also have values that contain other values. And this adds a really nice level of abstraction and sophistication to our programs. So the first one of these are lists. And so lists can contain multiple values sequentially. The way that we type them as code is that they begin and end with square brackets, just like how strings begin and end with quote marks. And we separate the values in them with commas. So I'm going to go ahead and go back to my interactive shell right here. And yeah, let's go ahead. I could type a square bracket with a string value Zophie, another string socks, and spot. If I run this, well, this is just like, it's an expression. It's just like when I entered 2. This is an integer value. It just evaluates to itself. And this is just a list value. And as an expression, it just evaluates to itself. But we could do something like, let's put that in an assignment statement so that we store it in this variable called pets. And then we can use this later on. Now, the way that we can access the values inside of a list are by using these square brackets with an integer index. So the position of the values in this sequential list, the sequential values in the list, that's called the index. And the funny thing about programming is that indexes begin at 0, not 1, which is kind of confusing for non-programmers, but almost every programming language begins at 0 and not 1. It's sort of weird if you think about it that the first hour of the day isn't 1 and it's not 0, it's 12, and then we go to 1 and then 2 and then 3. Anyway, yeah, the first index is always 0 in Python. So we can access, so this is the value, the string Zophi at index 0, because it's the first value in the list. If we wanted to access that, we could just have these square brackets and the integer 0 in there. And so this evaluates to the string Zophi. If we just type the pet's variable name itself, that evaluates to the entire list value right here. But we just want to have the first value at index 0 right there. And then later, we could also use this as the left side of an assignment statement. So instead of a variable that we're storing some value into, we can store a particular value at a particular index in a list. So pets, the 0 index value should be this new string. Let's just call it Simon. And now when I type pets index 0, that's going to be a different string. If I type pets by itself to display the entire string, you can see this value has changed. So there are 3 values inside this list. The indexes are 0, 1, and 2. And that's another common misstep in programming. If you have a list of 3 values, the last index isn't going to be 3, it's going to be 2, because we started at 0 and not 1. So that means if you try to access index 3 of this list, Python's going to give you an error. It's going to say index error, list index out of range, which you can kind of mean, you can kind of get the sense of that meaning, oh yeah, this is too large of an index for this list. So the neat thing is, remember, you can use an expression wherever you have a value, because it's just whatever that expression evaluates to. So if I say I want to have just a variable called I, which is a really commonly used name for a variable that just stores an index, I for index. Let's just say I is equal to 0. And then I say pets index I. Of course, this I is going to evaluate to 0, and then that's going to evaluate as pets index 0. We could even put more complicated expression in here. I don't know, I plus 1 times 2. And you know, the I evaluates to 0 plus 1, so that makes it 1, and then times 2, I guess, is times 2. So this is going to be the same thing as pets 2. This is going to be great because this means that we can write code that accesses this data. We don't always have to be explicitly typing out a variable. Now, there's a lot more to lists than what I've covered right here, but this is just sort of a broad overview of the Python language. I'm going to go into lists, and I'm going to go into another data type called dictionaries. And so dictionaries can also contain values. They're values that can contain other values. And dictionaries don't store the data they have sequentially, rather they store them as key value pairs. And they're also written with curly brackets instead of square brackets. So that's how you can tell when you're reading code the difference between a list and a dictionary. I'm just going to go ahead and jump into the interactive shell example right here. So let's say we want to store in a variable named cat. I'm going to start storing a dictionary, and you can tell because I'm using curly braces. And I'm going to have key value pairs, and you can access the data in a dictionary through its key. So, and a key is just some value. In this case, I'm going to have a string called name, and this will be the key, and its corresponding value will be a string called Zophi. And so notice I use a colon to separate the key and the value. It's kind of confusing because, you know, these string values are both values. This is just the key value, and this is the value, I guess. But we're just used to calling them as key value pairs. or just keys and values. And yeah, we can store multiple pieces of data in this dictionary. So I could say we'll have another string that'll be the key age. And this one will, the value for that will be an integer, 14, and legs, let's call that 4. And then I want to end this dictionary with the closing curly brace. So again, this isn't going to evaluate to anything. It's not an expression. This is an assignment statement, but it contains this expression right here. Whatever this value this evaluates to is stored in the cat variable. And we can use the square brackets to access data inside this dictionary, just like we use it, the square brackets to access data inside of a list, except instead of some integer index, we're going to have the key value. So I could say, hey, what's cat name? And this will evaluate to this string value right here, Zophie. Or I could get the cat age, and next year my cat will be 15 years old. Oh yeah, and then we can have like a string value here. So I have a string, and I'm going to use the plus operator to join it with another string. And that string is going to be whatever is at the value for this name key in this dictionary cat. And so this will be the string Zophie, and then Python will concatenate all of this. So no matter how complicated the expression is, it's still an expression. It's just going to evaluate down to a single value. And that's how we get my cat is named Zophie. So yeah, this is a really great, lists and dictionaries themselves can contain other lists and dictionaries. I mean, what if I wanted to have this cat dictionary? I could say food, and then there's a lot of different food that my cat eats. So the cat eats kibble and canned food. I'd have a list value where I'm storing all of the data here. And so now we have lists inside of dictionaries, and then you could have this, let's say if I had multiple cats, I could have this dictionary inside of a list of dictionary values. Lists and dictionaries are great because now you can start creating data structures that start representing real world objects. And then your program can start manipulating those data structures to help you, process some information. Yeah, so, and then keep in mind the main difference between lists and dictionaries is that lists store data sequentially, and you access them by their integer index. So that's always going to be 0 to whatever the length of the list is minus 1. And in fact, if you remember that len function that we were playing around with earlier, that can give you the number of characters in a string. It can also give you the number of items in a list, or the number of key value pairs inside of a dictionary as well. To find out about all this, you'd have to look at the documentation for the len function. You could just start Googling that and finding your own examples. There's a ton more to learn about this, but you can sort of start seeing like how we can create programs that can do something useful. If we wanted to have a chess playing program, we could probably create like a representation of a chessboard and where pieces are on the chessboard by using like a dictionary with a key value pair for each space, where like the key is one of the 64 spaces on the board, and the value is a string describing like white queen, or black rook, or something like that. And then we can have our programs just sort of start modifying that list according to like the rules of chess and trying out other things. And that's basically like, yeah, data structures is sort of how we can start creating representations of real world things, and then making use of the fact that computers are really, really fast at operating on data and processing data. Okay, so let's go ahead and let's see, are we going to, oh, right, okay. So up till now, we've been using the interactive shell, and we've just been running instructions one at a time just to see what these like little building blocks of programs can do. Um, Once we actually want to sit down and write an entire program that, we write out all the instructions and then we run the program and it just goes through the entire program. So that's going to be in a .py file. It's all the Python code. Generally, the program is going to start running at the very top instruction, and then it just goes down to the next instruction and so on. You can think of this sort of like, you can think of this as the execution. If you put your finger on the top instruction, and then after that executes, you move your finger down to the next instruction. The execution is sort of where you're pointing your finger, what line of code is going to execute next. And the way that it moves down, or the way that it moves through your program is called the flow of execution. And we can write code that controls that. Those are called flow control statements. That's a lot of fancy words for, basically it means we can write code that decides what parts of code we should run, what parts of code we should skip, what parts of code that we should run multiple times in a loop, that sort of thing. Those are flow control statements. Okay, so there's only a few basic ones. I'm just going to lightly cover this. We're not even going to be entering this into the interactive shell or anything like that, just because we'll be doing plenty of that when we actually start writing real programs at the end of this tutorial. So the first one is an if statement. So an if statement is made up of the keyword if. You literally type out the word if, followed by an expression that we call the condition. And then it's going to have a little colon at the end of it. And if this expression evaluates to the Boolean value true, then the Python will run the code that comes right after the if statement itself. Notice that we have a little bit of indentation right here. I'll go into that in a little bit. If this expression or this condition evaluates to false, then we're just going to skip this. So you can see I have like a little program right here. We've seen this before. My age equals, this is an assignment statement. We call the input function that lets the user type something into a keyboard. Now we call this, we have another assignment statement. We're overwriting the value in this my age variable with this. And this is the int function. This basically converts the string that input returns into an integer. And remember, if you don't really know what that does, you can just sort of play around with it. So input, and I guess I'll type 42. And so here I am just in the interactive shell, just playing around with this. Okay, my age, I guess this contains a string value 42. And remember, we can't really do math with string values. We have to convert that to an integer first. And so that's basically what the integer, the int function does, is it takes this and then it returns a new value, an integer value. That's the integer form of this, of the value in my age. Now, remember, my age is still that string value. This is just the return value of that. So if we wanted to update my age with the integer value form of it, we could run this code right here, and now my age is 42. Now, of course, we could see that right here. We could pass this, we could type this code directly in. And then, if we try to pass a string that it doesn't understand, it'll just give us an error message. And we can always just Google what this error message means and what causes it. So we look at this program, it's like, oh, okay, you're just entering your age. And then, well, this is an expression. Say you typed 29, because that's how old I am, sure. Then my age, this evaluates to the value stored inside of it. That would be the integer 29. And then 29 greater than or equal to 18. Well, that whole expression would evaluate to the Boolean value true. And so this says like, oh, okay, if this is true, and it is, if I typed 29 up here, then it would execute this code. And there's also something called, and if this was false, it would just skip this. Now, optionally, you can also have an else statement that can follow the if statement, and that just runs code if this is false. So if you only had this, well, it would run this code if the condition was true, otherwise it would do nothing. But if you add else after this, you can say, oh, okay, well, if this is true, run this code, but if it's false, then run this other code. And then, of course, right here, we have a comment right here. So you might be wondering, okay, so what's the code that it runs? Is it always just, it's not just the one statement following it, because you might want to have multiple instructions that it follows, that it executes if the condition is true. So in order to mark which instructions we want, we go ahead and indent that code a little bit. And this forms what we call a block, which is what this comment is talking about. So all of the code that any of these statements that end with a colon are always going to expect an indented block of code after that. So in this case, for an if statement, it's going to say, if this is true, run the block of code after this. And the block ends when the indentation returns back to what it was previously. So you can see right here, for else, this is matched with this if statement. And the else statement is just the else keyword followed by a colon. And so that's going to say, oh, okay, this is followed by a block, this indented block of code, and we're going to run this. This is inside the else statements block right here. Oh, and one other thing about Python variable names is that I gave a bunch of rules for what is a valid variable name. You know, they can have letters, numbers, and the underscore, but they can't start with numbers. Also, variables can't be Python keywords. So I can't have a variable named if. I can't say like if equals 42. Python will go ahead and say, no, that's invalid. Remember those import statements when I had import random? I can't use that as a variable name either. So those are keywords. Those are reserved because they have special meaning in the Python language. So similarly, you can't use else. But yeah, so again, this is just a little building block. We've learned about expressions. Expressions are just values and operators. We can put those together to build expressions. We can use expressions as the condition for an if statement that can conditionally run some code. We can also add this else statement right here to run code if that condition is false. A really nice thing is that, well, technically in this indented block of code, we could have other if-else statements and then other if statements inside of those. And so we can create this very complicated behavior of like, okay, if this certain condition is true, but then this other condition is also false, then do these other different things. And that's how we can build programs that have more complicated behavior. It's not just we're typing in 2 + 2 and it carries out that one instruction. Now we can type out a lot of complicated behavior that we specify here, and then the program can just carry it all out as fast as the CPU can run. Now the other type of flow control statement is a loop, and so this is when you have a bit of code that you want to run multiple times. Now what you could do is just copy and paste that code over and over and over again. I mean, that might be fine if you want to have it run twice or 3 times, but you know, if you want it to run 10 times or 10 million times, you don't want to have to copy and paste it over and over again. Instead, you can just put it in a loop and tell Python, run this loop 10 million times. Each time that Python executes the code, runs the code in the loop, that's called an iteration. So the most common type of loop is a for loop. And this syntax is somewhat complicated, but if you have some block of code, in this case, we have a block of code with 2 lines, print hello and print goodbye. Say we wanted to run that 10 times and we didn't want to copy and paste it 10 times over. We could have a for loop, and that is the for keyword, followed by a variable, And usually we just have it as I when we just want to run a certain number of times. And then the keyword in. And then there's this function called range that we pass it 10. Really the main thing that you have to pay attention to is this number right here. This tells the for loop how often we want to run this code. And in fact, if I just go ahead and copy and paste this, and then run this code, we can see it's run this block of code 10 times, printing out hello, goodbye, 10 times. So 20 lines of text right there. So this syntax is kind of strange. There's another use of for loops where you can run the code once. You can do one iteration for like each item in a list or each character in a string, and then this syntax makes more sense. But for right now, you can just sort of remember as, oh, for I in range 10. Now, this variable, this can be any variable name. It doesn't have to be I. This will be assigned a new value for each iteration of the loop. And in the case of this range function right here, range 10, I is going to be assigned 0 for the first iteration, and then 1 for the second iteration, and 2 for the third iteration. In fact, I could just go ahead and I just print I and save this, and then run it again. This is going to print out all the numbers 0 through 9. And just like how we have list indexes start at 0, the range function is also going to start at 0 as well, and go up to, but not including, this number 10 right here. Okay, so for loops are useful if you have a static number of times that you want to run some block of code. There's another loop called a while loop, and this will keep running iterations as long as a certain condition is true. And this condition, just like in the if statement, the condition is really just an expression that evaluates to the Boolean values true or false. Here we have a very short program. We assign this variable ask again to a blank string. It's just 2 single quotes right there. And then we can say while, this is the keyword while, and then we have the condition. So while ask again does not equal the string yes, and we have colon that basically marks this as like, okay, now we have another block of code that's indented. So we're going to keep running the code here as long as this condition is true. So when we first encounter this condition, ask again contains the blank string. So blank string does not equal the yes string. Well, that's true. So the execution will enter inside this block and then run print, do you want me to ask again? And then let the, it calls input and lets the user type something in. In fact, if I go ahead and copy and paste this code and run it. So ask again is blank, and this condition is true. So the execution ran line number 3 to print this out. And now it's waiting on me here on line 4 to enter something. So if I say no, so now the variable ask again contains the string no, and no does not equal yes, that is true. So now we enter the loop again. I can say no, no, do you want me to ask again? No, in, no. Well, then if I say yes, now ask again has been set to the string yes, and yes does not equal yes, that's false. So since the condition is false, we no longer run another iteration of this loop because we're only running iterations of the loop while the condition is true. So once this becomes false, we continue on to the rest of the program after this block. But there's nothing at the end of it, so we've reached the bottom of the program, so it stops. So of course, this is completely confusing, right? It's sort of doing the opposite of what we want. Remember, programs will do exactly what you tell them to do, even if it's a really absurd thing. So this, you might consider this a bug, or maybe you wrote this program to annoy someone, in which case it's working perfectly. So yeah, we have for loops that can run a certain number of times, like 10 times or 20 times. We have while loops that can run as long as a certain condition is true. Um, we have a couple other flow control statements that we can only use inside of for and while loops. These are pretty nice. They are just the keyword themselves. A break statement is just the word break, and a continue statement is just the word continue. If your code executes a break statement, it immediately exits the loop. It goes just past to the first instruction after the end of the loop's block of code. So you can think of this as, we call it breaking out of the loop. A continue statement, meanwhile, will immediately go back to the start of the next iteration. So you don't want to run the rest of the code in the loops block of code. You just want to go back to the start and continue at the next iteration. So we can do something like that. Usually we'll have like an if statement to conditionally run a break or continue. So for example, in this code, we have while true. Now the condition is just the value true itself. So this is always going to be true. Remember, we had we have an expression 2 plus 2 that equals, that evaluates to 4, but the value 2 just evaluates to 2, and the Boolean value true just evaluates to true. So this is a condition that will always be true. So this is going to be an infinite loop. And if we don't program the rest of this carefully, the computer is just going to keep looping through all these instructions forever until we shut down the program. Just like I had to shut down the mu editor. It got stuck carrying out instructions, and I just wanted it to quit. But we can do that. We can break out of the loop with a break statement. So right now we have print, would you like to quit? That'll just display this text on the screen. Then we let the user enter something, and we'll store that text that they entered into a variable called doQuit. So here, oh yeah, the keywords are case sensitive. So if and while and import, and also the function names as well. All those have to be lowercase. Just like the doQuit variable, I signed it using a capital Q. So when I use it later, I need to use a capital Q. So if doQuit, the text that they entered, if that equals yes, then we'll break. So we could, so if this condition is false, doQuit was something else besides yes, then the execution just skips past this block of code. So we can see right here, there's a block, an indented block of code inside this other indented block of code. So if this is false, we just skip this code. If it's true, we run this code. But if we skip this code, we're at the end of the loop. There's nothing else. But since we're inside this loop, once we reach the end, we go back and we check, okay, is this condition still true? In this case, it's always going to be true. So then we enter the loop again. So I can say this and then run this. If I say no, it will just continuously ask me that. In fact, even if I said yes with all capital letters, well, that's not the same as yes that is lowercase. So it's going to loop again. It's only until I say yes that doQuit will have yes in it, so that this condition is true, and then we break out of this loop. And then we go to the first instruction after the end of the loop, but there's no more instructions, so the program just ends. So break and continue we use those inside of loops only. Loops are a great way to run the same block of code over and over and over again. And we can have loops inside of other loops. We can have loops inside of if-else statements. We can have if-else statements inside of those loops, just like we have right here. And so once we start combining these small building blocks together, that's how we can start creating programs that exhibit very complicated, sophisticated behavior. Now, the final flow control instruction that I'm going to show off is the def statement, and this is so that you can define your own functions. So a function is really nothing more than just a block of code that you execute whenever you call the function. So here we're defining the function right here. You can see it ends with a colon, just like the while loop and for loop, meaning it expects an indented block of code right after this. So here's how we create a function. We have the def keyword, and then we have the function's name. This is the same thing as like variable names. It's letters, numbers, and underscores, but it can't begin with a number. We have the open and close parentheses, and then we might want to pass some argument values as input into this function. Remember how we have the we have that length function. We can pass hello, and then this returns a value, in this case 5. In our case right here, our function greet, it will run, it will call the print function 2 times right here, and then it returns to wherever we called it. So creating your own functions is a great way to save yourself from copying and pasting code, because instead of, we call this function twice, but that saves us from having to copy and paste this. Now, I think I'm getting ahead of myself right here. So we have length. We are passing this value as an argument. Its input into the length function. You can see the same thing right here. We're calling our function greet, and we're passing it 2 values. And since we're passing more than 1 value, we just separate them with a comma. Usually the way that we write Python code, we put a comma and then 1 space after it just to make it not look all bunched together. But Python technically doesn't care. But yeah, we separate it with commas. So this value, this string value morning, this is going to be assigned to the time of day variable. And this string Alice will be assigned to the name variable, because this is the first argument. We assign it to this first variable, and this is the second argument. We assign it to the second variable. So how the flow of execution works is we start at the top of the program, which executes this def statement. Now here, we're only defining the function. We're not actually calling it. So the execution is going to skip all the code. It's not actually going to run this. It's just saying, okay, I now have a function called greet. It contains this code. Here, we're calling that greet function, and we're passing these values. So those get assigned to these variables. And now we start running this code. Good morning, I guess, because that's what's in the time of day variable. So good morning, Alice. And then we print, how are you? And here we've reached the end of the code inside the function. So now, this is kind of interesting. It will return to the line that called this function. And then we just continue going down to the next instruction, where we call greet again, this time passing evening and Bob, which get assigned to these variables. And so this is going to print out good evening, Bob, and then print how are you, and then return again here. Now, this is a basic building block, just like if else and the loops. We can have function calls. We can have functions that call other functions. In fact, that's what we're doing right here. Our function greet is calling the print function. Now, print comes with Python. We don't have to know how it makes text appear on the screen. We just have to know, yeah, when we call print and we pass it a bunch of values, it makes it appear on the screen. Same thing if we handed our program to someone else. They wouldn't have to know how our greet program or how our greet function works. They just know, yeah, just pass it the time of day and then the name of the person that they'll greet. Pretty easy to reverse engineer this, though. It's like, oh yeah, it just displays these, it prints these 2 lines of code. That's easy enough to solve. But again, inside this function, you can have loops that contain if-else statements that themselves contain loops that then call other functions. Like maybe have a loop that calls a function 10 times. The amount of complexity that you can build by combining all these pieces together is pretty high. And yeah, and remember I said that function calls, uh, they could be part of expressions. They evaluated some value. So if you had 2 plus length hello, I mean, this is sort of a really contrived example, but we're passing the string value to a function call to len, and then this is going to return 5. It evaluates to 5, and so this entire expression is the same as 2 plus 5, and that's why it evaluates to 7. In order to specify what value the function call is supposed to evaluate to, we specify a return value with a return statement. So here we have a get favorite pet function that we're creating, and we have one argument, pet type. And when we call this code, it just prints out what is your favorite, and then we have pet type. So I'm going to say cat in this, and it has a little question mark that we display afterwards. And then we call input to let the user enter their favorite pet, and then we return that string that they typed. Now, of course, at the first time our Python program encounters this is just a def statement. It's just defining the function. It's not actually running the code in it. It's just saying, oh, okay, I've defined this new function called get favorite pet. You know, it takes one argument right here. So that way, later in the program, when we call it, we're going to pass cat. So it's going to say, who is your favorite cat? And then the user can type something because that's what input does. And then it returns whatever they typed. So the value inside this favorite pet variable right here, this gets returned from the function. So this entire function call evaluates to whatever value right here is returned by the return statement. And then in turn, that gets stored into this favorite pet variable right here. Now there's a lot more to functions, but this is mostly just to show you like, oh, hey, you could have your own code in a function and then call that function multiple times. That's really nice because it saves you from having to copy and paste the code of that function over and over again throughout your program. And that's really great because you don't want to have duplicate code inside your program, because later on, if say you want to update this code, have it change the text in here, or maybe you discovered a bug in this code. If you've copied and pasted that code over and over again throughout your program, you're going to have to make that change to every single instance that you've copied and pasted. And that's a lot of work. You might forget one instance, and then you have like another, like the bug is still in some parts of your program, but not others. The benefit of creating a function and then calling that function multiple times is that there's only one place that you have to modify the code. So, you know, again, it's just how loops can save you from copying and pasting code. Functions can do the same thing as well. Now, this is all a lot of information that I've thrown at you. You know, data structures and lists and dictionaries and flow control statements and data types and variables and everything. These are all the basic building blocks. And, you know, individually, they're sort of easy to understand. But I feel like the best way to learn how to program is actually diving in with some small programs that you start typing yourself. We're going to go to break, but before we do that, I just wanted to talk about creating programs. And this is the part where I start plugging my books. Hi, I'm Sweigart. I write books that teach people to program. And I also put them online for free at inventwithpython.com. So you can download the full text of the book. Or just, you know, if you're ever like, if you own a hard copy and you don't want to like grab it, you can always just open a web browser and go to inventwithpython.com. So, you know, I'm mostly known for this book, Automate the Boring Stuff. This is for complete beginners. It teaches you programming, and then it teaches you a bunch of modules that do useful things like update spreadsheets or send out automated emails and that sort of thing. And then once people sort of learn that, they sort of start like, okay, I know how to write programs, but I want to learn how to write programs the way professional software developers do. There's like a lot of best practices and things like that you sort of pick up with experience, but it would be nice if they were written down somewhere. So I decided to write a second book to sort of follow up this book. And that's nice. This is sort of an intermediate level book, but I started thinking about beginners again and how, uh, even if you know all this Python syntax stuff, that's not really the same as knowing how to put all those building blocks together into the cool thing that you want to make, something like that, this ASCII art, this text-based animated fish tank or something like that. Like, okay, you probably know that, print calls are involved here because they're printing out text, but like, how does all of that, I don't know, how do you go from learning the syntax to learning this? And so the main way that I learned how to program using the programming language BASIC um, was that I found other people who had written programs and saw what they had made, and then just started like copying those programs and then making little edits to that. And so I've created this huge collection of programs, including this little fish tank one that is coming into a new book that's going to come out in June called The Big Book of Small Python Projects. But all the projects here you can download and just read through the source code. And so in the next, after the break, we're going to start taking a look at some of these programs ourselves, and you can sort of see how all these building blocks create programs that do a fun little game. All of these projects are really short. They're all text-based. You don't have to install additional modules or anything like that. It's just to give people and they're not that entertaining. They'll be amusing for about 30 seconds, but hey, they're really short programs, so they don't have to be all that great. They just have to give you some purpose. You're not just doing programming practice exercises with really contrived examples. So I've selected 3 projects from this book because this was the way that I learned how to program. I have a copy here. There's a book that was first published in 1978 called Basic Computer Games, and it didn't really teach you the basic programming language syntax. It sort of assumed that you knew that already, and then it just had a whole bunch of source code to small little games and little simulations and animations and things like that. I thought like, oh, it'd be great to have something like that that's updated for Python. So that's the sort of things that we're going to look at, including that fish tank. But let's take another 8-minute break. I'll go ahead and start this timer. And I'll leave you with like another animation of a duckling generator program that I created. So yeah, I'll see you at the end of the break. Feel free to leave any questions that you have in chat. All right. Okay, and we're back. Yeah, okay, so David had a question. Is there a point at this stage of learning where you need to start thinking about which data structure would be quote unquote best for a given project? Like, do you need to have an awareness of whether a list would be better than a dictionary or vice versa? And I think you'll probably learn that you'll pick that up on your own once you start writing your program, and then you realize that the data structure that you chose, it's really hard to write code for that. So, for example, if you wanted to create, some piece of data that represents an employee, I mean, you can have strings for like the employee's name and maybe an integer for the employee's salary information, and you would want to combine that into a dictionary with the keys name and salary. And so you say like, oh, okay, that works. Um, but then, if you had thought, okay, well, I'll just have a list and I'll just have the first uh, value in that list be a string, and that'll be the name. And then the second value will be the salary information. Um, Actually, let me go ahead and write that here. So say, you know, I just had this list and I said, okay, this list represents an employee. If you later come back like 2 weeks after you've taken a break or something, and you look at this code again, and you see this list, and you're sort of like, oh, okay, I guess the first value in this list is the name, and then this is the salary, or was this number representing something else like that? Is this like how many years they've been with the company, or something like that? You can then start thinking like, oh, it's actually kind of not too useful to have this sort of information organized in a list, whereas um, if you had it organized as a dictionary that your program is later accessing with this name and salary keys, then your code becomes a lot more easy to read and understand by you, the human programmer. And that's actually a really important thing with programming, is that Python as a language is very high level. Um, a lot of things are happening behind the scenes on your computer by the CPU when you run a single instruction like this: create a dictionary with these keys and store it in a variable called employee. Um, because originally, like, your program, CPUs are just running very basic instructions of just like, oh, set this bit to 1, add these two numbers together, store that at some other memory address. Um, and then we started thinking like, hey, how about if we wrote software that helps us write software? And so now we have software such as the Python interpreter that we can just type uh, more, not exactly English, but sort of more human instructions, like, oh, while this condition is true, do this sort of thing. And the Python interpreter will then convert that into the basic instructions that your CPU carries out. That's that's sort of a very, very brief summary of what's going on. And if you really want to learn more about how that works, you can get a computer science degree, I guess. Um, but it's what's really nice though is that using a high level tool like the Python language, you can get a lot done in a very small amount of time. It's sort of like when you download and install other people's third-party modules. I don't know how to write the code that will post something to Twitter, but that's okay. I can just install the Twitter module for Python and read the documentation to figure out what functions to call there. And the code inside that module handles all those details for me. That's basically what programming has been for the last 70 years or whatnot. That's We're just creating these abstraction layers on top of abstraction layers on top of abstraction layers, just to make writing code easier for humans. Because remember, software engineers are very expensive. So if you can find ways to save a software engineer time, you can produce software much cheaply. And it doesn't matter if that software is like a little less efficient. Like, Python might be carrying out some instructions that it doesn't necessarily have to do. Um, but that's fine because, well, computers are cheap. We can just throw more computing power at some problem if we really need it done faster. Yeah, so it also kind of comes down to like your own opinions as you learn more about which data structures to use or which algorithms to use. You'll get more insight into this, which is why I like going into the programming approach. Like here's a program, take a look at it. We'll try this out, and then you can see how other people write their own code, and then that gives you insight about how to write your own code. So speaking of which, let's go ahead and start coding. And again, feel free to like put any questions you have into chat, and I can answer them. So the way that we're going to program right now, we don't have that much time left in the tutorial. It's going to be pretty artificial compared to the real way that people write programs. So I'm going to give the source code, and I'm going to insist that you just copy the code by hand, type it in yourself. That sort of, if you just copy and paste it, you don't really get a feel for the actual, like what the instructions that you put together are, and also the sorts of typos and mistakes that you can make along the way, although we might be a bit crunched for time. But yeah, so we're going to just be, straight writing code. But writing a program is kind of like writing a novel in that you don't just sit down and start typing chapter 1 and then you're done with chapter 23 and you're done with the book. You're going to be going back, making edits. You're going to be rereading through different parts and seeing if they make sense. And so, what I sometimes like to do is just take a sheet of paper and just sketch out a really rough flow chart, with pencil or pen. Or sometimes I'll just open up a blank file and then I'll just start typing the comments because Python will ignore those. But I'll say, okay, at this point in the program, I want this to happen, and then later I want this to happen. And then I'll just start filling those in with the actual code that carries out those ideas that I've written down in the comments. But here we go. I'm just going to go ahead and paste all 3 of these into chat. So I have the code for these programs. We'll start with guess the number. And so this is a website called Pastebin. Pastebin is great if you have a large amount of text to share, but you don't want to copy and paste it into an email, especially with Python code, because oftentimes if you copy and paste code, your email client will mangle the indentation, and it might get rid of the white space indentation right here and cause everything to be, have the same indentation, and then your code doesn't work. So to preserve all of that, it's really nice, just also in general, to post it to a Pastebin website. Pastebin.com was sort of the first of those websites. That's why it got its name. Well, that's why those sites got named that. And then you can just share the URL. So here, I'm going to go ahead and this is going to be really tiny. Let me see if I can increase the size of this. So this is going to be a guess the number program. I also have that. Oh, stop these ducklings. I also have them already just to give you an idea of what it looks like. So this is going to be a guess the number game. It's going to be really simple. It thinks of a random number, and then it asks us to guess, and it'll tell us if our guesses are too high and too low. So here's what the program looks like. I'm thinking of a number between 1 and 100. Take a guess. You have 10 guesses left. So you can just sort of split the difference in the middle each time. So 50 is too low, so I'll go with 75. That's still too low. I'll go with 85. That's too low. 95. That's too high. 90. Well, I have 5 guesses left, so it's in between 90 and 95. So 92, 93, 94. And yay, and if you follow that strategy, 10 guesses is plenty. So yeah, this is a very simple program. A lot of introductory tutorials have it. Let's go ahead. I'm going to go ahead and type this out. And just because we are running low on time, I'll go ahead and just sort of explain how the program works as I'm typing it out. So let's see. First of all, we're going to have random numbers because we need to come up with a random number for the computer to have the user guess. So I'm going to import random, and that'll give me access to the randint function that I showed earlier on. Then we'll just display the title here. So we'll say guess the number. Then we call print with no arguments. This just prints a blank line just to add some spacing in there. Now I want to come up with the random number. So I'm going to say random.randint. I want a random number between 1 and 100. And I'll store that in a variable called secret number. And you can skip copying all of these comments as well. So at that point, I'll display, I am thinking of a number between 1 and 100. Now here, we're going to want to constantly ask the user to make a guess, and then we'll have to tell them if that guess was too high or too low. And then, unless they actually guess the number, we're going to want to repeat that. So we're going to need some type of loop. We're going to give them 10 guesses. So that's a static number of iterations that we want to run that code. So I'll just use a for loop. So for I in range 10, and then we'll have an indented block of code. So here I'm just going to tell them how many guesses they have left. So remember, this I variable is going to be set to 0 on the first iteration and then 1 on the second iteration. So the number of guesses that they have, if we just think about it a little bit, well, that's going to be 10 minus I. So I could say you have, and you can pass multiple arguments to the print function. So you have 10 minus I. I don't think you need to have the parentheses right here, but I just like to have them just to make it a little bit easier to see this code. And then here, we want to ask the user to enter a guess. So we're going to need to call input. Input can also take a little string argument right here, and it'll display this as a prompt. So I just wanted to have like a little angle bracket as a prompt. And this will return the string of what they type, but we're asking them to guess a number. So I'm going to take what this function call returns, and in turn, that will be passed to the int function, which remember returned an integer form. And then I want to save that integer form to the guess variable. And feel free to go ahead past me if you're typing faster than I am. So now I need to check okay, well, if they guessed correctly, I want to break out of this loop with a break statement. Otherwise, I want to tell them if it was too low or too high. And say if guess equals the secret number. And remember, integers for the integer 42, that's going to be not equal to the string 42. And secret number is going to have an integer because that's what randint returns. In fact, we could even do this in the interactive shell if I just sort of forgot what exactly randint returns. I could just run it right there and say oh yeah, it returns an integer. So if they did guess it, I want to break out of this loop. So I want to stop asking them over and over for their guess. Otherwise, if this is false, well, then we'll just continue on with the rest of the code in this block. I'll say if the guess is less than the secret number, print your guess is too low. If it's greater than the secret number, I can say your guess is too high. And usually at this point, I want to make sure wait, do I have this backwards? Because that's an easy mistake to make. Yes, if the guess is less than the secret number, I want to say your guess is too low. It's really easy to accidentally click the wrong one right there and cause a bug in your program. And then after it tells them if it's too low or too high, it will then loop back to the next one. Now, the other way that this loop is going to stop looping is that if we've run through 10 iterations, then it will continue past this. So So once we're at this point in the program, either the guess is correct and we broke out here, or the guess is incorrect, but we stopped looping because they ran out of guesses. So we have to check again. If guess is equal to the secret number, we can just print something like, yay, you guessed my number. But then if that condition is false, we can say game over, and also tell them what the number was. The number I was thinking of was, and then we'll just post this secret number. And then I'll just save this as guess. Well, I guess 2 for me because I already have a file named guess. And of course, I've only written this code. I haven't actually tested it, so I have no idea if this works or not. I'm going to have to run it and then try different things, you know, too high, 25, too high. Oh, that's great. I guess the number, and then maybe run it again, but this time purposefully lose by running out of guesses and make sure it displays the correct word. There's all sorts of things you can do to test your programs. You want to make sure that it works in all the expected cases. And so this program pretty much does it combines all the things that we've learned in this tutorial. Importing modules, printing stuff to the screen, calling functions and passing arguments to them, and then saving that return value to a variable because we're going to use that value later on in our program. And so the really nice thing about this is we haven't hard-coded any sort of number. We could make a change right here. Like I'm going to comment out this code by putting a little hashtag here. So now the computer is going to ignore all of this code right here because I just want to temporarily say, I'm just going to set the number to 42. Now when I run this, the secret number is always going to be 42, and that's not going to be really a lot of fun. That doesn't have a lot of replay value because the number is always going to be 42. But by using this function, randint, well, now this game is a bit more interesting. It's always going to be different each time you run the program. Let's see. Okay, so at this point, we have run out of time. On the run-throughs of this, I had a little bit more time to at least go into the second program. But I guess I can also, before I stop completely, one thing else, another thing that you can do is just select all. I'm going to hit Control-Alt to select all, Control-C to copy, and I'm going to enter all of this into that pythontutor.com website. Now, the really nice thing about this website is you can click Visualize Execution, and this is essentially a debugger in that it shows you how your program runs one line at a time. So you can see right here, the execution is right here on line 1. Just imagine you have your finger on your code and you're following what line is currently executing. So I'm going to click Next and execute that. So this is a little complicated right here, but you can see, it's now defined this random thing, and that's pointing to some module instance. So it's basically saying, it's imported the random module. And now the execution is right here on line 3. It skipped line 2 because that was blank. And here's the output of our program right here. So that's going to display guess the number and then a blank line. And then I click Next here, and we can now see, the secret number, that variable, is going to be set to 50. That was the number that was returned by randint right here. And so I can click Next, and you can see it now prints. I am thinking of a number from between 1 and 100. And here we can see that the execution enters inside this for loop right here, which is going to say, hey, you have 10 guesses left. Remember, the I variable right here on the first iteration is going to be set to 0. We can see that right here. So this is essentially what a debugger does. It lets you step one line at a time through your program. And in this case, for Python tutor.com, it lets you and simulate what the user enters as well. So I'm not going to enter 50. Well, yeah, I'll go ahead and enter 50 and then click submit. And so that's essentially the same, that runs this code. And now we can see that our guess variable also contains 50, which is why, hey, if 50 equals 50, and I click next, break. So the execution has moved inside this if statement because this condition is true. And when it executes break, it breaks out of that loop and then goes down here and then also does a comparison again, in which case, 50 is still equal to 50. And that's why it will then print, yay, you guessed my number. So pythontutor.com is really wonderful. It lets you see how your code is running. It only works, like you can't open and close files on this because it's a website. You can't use third-party modules or anything like that. But for a lot of the basic programs that you'll be writing when you first start out, Python Tutor is really wonderful to see how your program works. Yeah, I can go ahead and I'm pretty much at time. So I'll go to the lounge of the PyCon website, and if you have more questions, you can ask me there. Just to give you a little example of what the other two programs were, one was this Magic Fortune Ball, which is basically a Magic 8-ball. I didn't know the copyright issues of using the original name, but just how like that Magic 8-ball, you can ask a yes or no question, and then it will display the answer. Which, of course, the program does not predict the future at all. It just randomly chooses an answer, either yes or no, or ask me later, or something like that. And again, this is just a very simple, short program. It's about 50 lines long. And for the other one, I have something called a Million Dice Roll Statistics Simulator. So if you have 2 dice, rolling a 2 is very rare because you have to have both dice come up with ones, whereas rolling a 7 is really common because you can have 1 and 6, or 2 and 2 and 5, and 3 and 4, and so there's a lot more combinations. And so this basically simulates rolling a bunch of dice. In fact, a 1 million dice, and you can see the if I say let's roll 2 6-sided dice 1 million times. So in those few seconds, we've just simulated a million rolls, and now we can also display the percentage of how many of those rolls came up 2s, how many came up 3s, how many came up 7s, and how many came up 12s. And so that's how you can have a computer sort of do the heavy number crunching. And again, this program is about 30 lines long. It's not that complicated. You can take all the little pieces that you've found and start seeing how they're put together into these programs. Again, my website is inventwithpython.com, and I also have a collection of these programs. These are linked on the inventwithpython.com website, but a more direct link is here in this GitHub repo. In the source games by example, there's a README program, but I have a bunch of these little programs. Some of them are more complicated than others, but as you get more and more experience with Python and you want to see how all of these concepts come together to actually create fun little programs, you can check these out.
And Al, there was one question in the chat, if you can answer that one.
Oh, yes, okay. Yeah, you said that all Python programs read from top down. I've seen some sites that said you should instead use code to start your program. Oh, yeah. So the if name equals main. Yes. So this is a bit more of a complicated thing. I can cover this real quick. Let's go back to this guest program. Notice how I don't have any functions at all in this. What I could do, and this is something that really came from like the C programming language, is that they would define a main function. And how do I indent all of this code?
Tab?
In Mu. I think it might be. Okay, well, let me just do this in Sublime Text instead. This is another editor that I use. I can, oh, actually, yeah, I think it might be tab. Yes, sorry. What old C programs would have is they would have a main function And so that main function would be the starting point of the program instead of just whatever code was at the top. And then at the bottom, you would call main. This doesn't really do anything. It's, we're defining this function and all this code, and then later we call main. But one reason you would want to do this weird bit of code in Python, there's a special variable that has double underscores, name, double underscores. And if that has a special value, double underscore main, this string, we would call the main function. So the reason that we have this is if you run this guess program directly, then this special name variable would contain this string. And so then we would say, oh, okay, you want to just run the program because you've run the program directly. But you can also import Python programs from other programs. And if you imported this guess the number program, say it had some functions that you wanted to reuse in a different program, when this code gets executed, when the program is imported, the name variable will have a different string. It'll be guess2.py or something like that. So it won't be main. In which case, like, oh, because we imported the program, we don't want to run the main part of this program. So this is an idiom in Python programming that lets you that lets your program work whether it's run directly or if it's imported as part of another program. Because otherwise, if you didn't have this, if another program imported this program, it would run all of the code immediately as soon as that program ran its import guess statement, which might not be what you want to do. You might want to just import guess so that you could later call some of the functions in the guess program. But yeah, if anybody else has other questions, feel free to post them to chat, or I guess I can join everybody in the lounge. Yeah, this has been really great. Thanks a lot, everyone.